Hello guys, today I will make a tutorial about nested tree views in C# WPF. As you know, nested tree views are a little bit complicated because each different object has different layers and different levels. But I hope after today's tutorial you will easily be able to do them. So first we start a new project. So we will have a tree view in our project, and each level will have a different structure, and depending on what we are showing in the tree view, we will have this different type of structure. So let me give you an example. We have an object type of a car, we have a motorcycle, and we have a bicycle. Okay, so when we open this up, we see that the car, it has 5 different subcategories: basic information, mechanic, electronic, interior, and body. And the information, it contains directly the general information, but when we go into mechanic, you see that there's 3 more subcategories in mechanic, and this is only special for mechanic. For example, in the other ones, these are not the issue, as you see. And when we go into engine, we see the properties of engine, transmission, and chassis. And this is the car object. When we go into the bicycle, we don't have electronic, interior, or body. We only have general information. And the general information of the bicycle is only about the bicycle. It's different from the car. And the mechanic also, it only has like basic transmission properties, and the chassis has different properties. So this is what we achieved to do. In this way, you have unlimited options to do whatever you want in the tree view. And also, the tutorial is not only making the tree view. Also, when we change any data here, like if we change something here and press enter, it also updates the database. So it's also a two-way it also has a two-way binding in the data, and we will do this all programmatically, not inside XML. So and one more thing I don't want to forget to mention about is when we right click on the main category, there's an option to delete it. So main categories have different clicking events, and when we go into a subcategory, we have a different type of event. When we right click, we can paint it red. This is just an example event to show that, you know, the events can also be specifically designed for the level of the tree view. So I think this is like what you can ultimately do with the tree view, and this is quite enough to do anything that comes into your mind. And also, after you learn this, you can not only be limited, you will understand the concept of being able to do anything you want with the tree view. You can even put a small thumbnail and play a video, or you can, I don't know, you can put some grid here, or you can put something else, or you can put a canvas and make drawings on it. So after this tutorial, hopefully you will learn them all. So I have the finished project here. You can download it from GitHub. The link is shared publicly and it has comments on it. So our target is to make the same project, and I made it in before, so it would be easier to go over it step by step. So now I will close this one and open a new project. Next, nested tree view. I will use .NET 5.0 There's some minor differences in .NET 5.0. I will also explain them on the way. As you see, in .NET 5 there is no resources file, so I want to have a file where I can use the images inside as icons, and I will use them as image sources. So what I will do is I have to create a new resources folder. I just right click on the name of the project and I add new folder. I will name it resources. And now, as you know, the project is in my desktop. I can either go from my desktop or open folder in File Explorer. Now I will put all of the necessary icons that I will use. So I will just copy it from my old project and copy it into my resources. And now you see all of them arrived, but I cannot use them directly, because if I use them they don't show up. In .NET 5.0 you need to select them all, and you need to go to properties, and you need to change the build action into resource, or it doesn't show up. It just shows up blank. So this is what you need to do in order to use it as a resource. And in framework there's already a resources file, and you just put them in and you right click on them and select include them in your project. In .NET 5 that's not necessary. You just need to select the build action into resource. Okay, so I just copied it from the other project. You see we have a Treeview named TV stock vehicles. I always put abbreviations of what type of object it is in the beginning. So TV stock vehicles is the Treeview that shows all of the vehicles that we have in stock. And my example is finished. Now I'm going directly into the code. First I need to create sample objects. Normally in your application you will use a database, and you have to read the database to get what objects you want to show in the Treeview. But in the sake of this tutorial I just made it hard coded and created 3 example objects. So the category of our objects is car, motorcycle and bicycle. First I will create them as classes. Okay, so we have a car object, a motorcycle and a bicycle. Now this is basically the structure of our Treeview. They share the same structure. So we have a car class. Inside our car class we have other classes: info, mechanic, electronic, body and interior. As you remember from the Treeview, when we open the first Treeview item, when we expand it, we see 5 subcategories under it, and this is basically the same structure as the Treeview. This is how we have to design it. And inside info we directly go into the properties. We don't have a subcategory. Inside mechanic we have 3 other subcategories, which are engine, transmission and chassis. And under mechanic we have 3 classes again, which are engine, transmission and chassis. So basically it's a class in class structure. The main class is car. Under that we have info with directly displaying information. We have mechanic with 3 more subclasses, and under these subclasses the information is displayed. And in electronic there's no subclasses, body no subclasses, interior no subclasses. and this is the structure of car. So we have to create the classes and subclasses. Also, we need to make instances of each class. For example, we have info, mechanic, electronic, body, interior. So we need to declare an instance of this class. So when we access an instance of car, and when we write car.info, an info object must be declared already so we can start using it and setting the data in it. If we don't use this, these are only declaration of classes. They don't have any actual instances, so there's no existing object. So we need to make an existing object under the main class so we can access them. And if you have a subclass, you need to do the same in that as well. I have under the mechanic class, I have 3 subclasses, and I also have to make instances of these subclasses as well. This is not a lesson, this is not about Treeview, it's about general information about classes, but just as I'm going over it, maybe some of you may not be so familiar with classes and starting C# recently, so it makes this lesson longer, but I prefer it being a few seconds long so anyone can benefit from it. So we have our car structure. In our motorcycle, we have only 3 classes because as you know, motorcycle doesn't have an interior, so the motorcycle class does not require an interior. It only has info, mechanic, and electronic. And the mechanic class has 3 subclasses as well. This is similar. And our bicycle class, it only has info and mechanic. It has 2 classes. And in the mechanic class also doesn't have an electronic subclass, and the properties are much more short. So we have 3 distinctive classes that differ from each other, but they will be all displayed in the same tree view. So this is our goal for today. I think with this structure the possibilities of doing anything is possible. So let's begin. So we have our objects. First we need to create samples of them. So we have in our sample project, we already have create sample vehicles. So I will add this method here. So what create sample vehicle does is it just declares hard-coded members of car, motorcycle, and bicycle inside an object list. So the Treeview source will be a list of objects named vehicles in stock. So we will use this sample class to create one car and declare all of the properties and give values. You see the name, like there's so much information I did just so the tree view looks rich. And then in the end I just add this, I cast it as an object and I add it to the list. I didn't want to make 3 different lists, one list for cars, one list for bicycles, one list for motorcycles, because I wanted to keep them clear. So I declare them as objects, add them to one single list, and then I will distinguish them by their type in the future. So we have create sample vehicles. I just you see when I enter subcategories, sample car.mechanic, under mechanic there's engine, under mechanic there's transmission, because as you remember the mechanic class has a subclass. So you can just make your classes all like this. If you don't have a subclass, you can use it directly under this. You can write the property after the first class. So we have to call this method as soon as the form opens. Normally this is the part where when you open the form you load all of your data from the database, but for this tutorial we don't need a database. I just populated the list from code. So we have a populated list with 3 vehicles inside, 1 car, 1 motorcycle, 1 bicycle. And now I have to start populating the tree view with the objects in vehicles in stock. So I will make a loop and I will iterate through each object in vehicles in stock, and I will distinguish them. If it's a car, I will add a tree view item with a car template. If it's a motorcycle, I will add an object which is in the format of a motorcycle, and if it's bicycle, I will do the same. So I will do this in the window loaded event. The reason of that is I want all of the user interface elements to be drawn so I can access their actual width and actual height properties, because when I create objects from code, I will adjust the margins and tree view widths from the actual height. I will give a ratio for it. You will understand what I'm saying when the moment comes. So first, let's go over car. So I start with a for each loop. For each object v in vehicles in stock. So we will go over each object one by one. As you know, there's 3 different type of classes in one list. So I declared them object because the object is the highest class, so everything can go under it. So what I will do is I will separate them here. If v is car, so if it's a car, it will go into this block. If v is a motorcycle, it will go here. If v is a bicycle, it will go here. So I distinguished 3 type of objects. Each one of them will go into their own block and be created in their own special structure. And now the car, what I have to do is I need to create a tree view. Okay, and this tree view will get the information from the main class. So first what I do is I create a tree view item. I create a tree view item, and when I name them, I want to put a number at the end of them. So in the future it will be useful to know when you click on the tree view or when you iterate through them for just any reason. Knowing what level they are can give you some advantages. So you can just use, like, if Treeview's name, if the final character of the name is 0, you can understand the level of the Treeview. Of course, there's other ways, like if you can count the children of the Treeview. If it has 0 children, it may be a parent, but this is not a safe way because maybe the Treeview may have no objects in it, but still it may not be a parent. So the safest way to do this is when you're creating it, just put a number at the end of the name so you can use it in the future. So we iterated through objects. We said if V is a car, then we have to cast V as a car. We will say car equals V as car. So now I have a car object which I got from this list, and you see our car class, we have all of the data that's in here, and it's set and it's full of information. So I have my car class. So I will create a Treeview item and I will name it with the level number at the end, and then I will use the tag property and write the type on it. This is also something that I use. The tag is very useful. When you click on a Treeview, you can understand what type of which class it's created from the tag. In the main tags, I use the type name. In the children class, I will use something else. So basically, I use the tag to pass the information around. In the future, when I click on the Treeview item, I can have information here that I can use in the future. Then, this is the important part. I'm creating the header of the Treeview. So basically, the header is the part that you see in the Treeview. So here, this is the header of object 1. So this is my car object, and you see when you click on the header, it becomes blue. And I want to create this header object from the information in my car instance. So what I do is I cast my car, and then I create a stack panel. And it's important, if you make the orientation horizontal, the writing will be on the right side of the car, of the icon. If you make it vertical, the icon will be on top and the writing will be lower. So basically the stack panel will be stacked from left to right if it's horizontal, if the orientation is horizontal. If you make the orientation vertical, it will be stacked up to down. So in the comments, someone asked, how can I make like an icon with letters on the bottom? This is the answer. You just change the orientation. If you make it vertical, it will go up to down. If you make it horizontal, it will go left to right. And we have the image. This image, you see, we declare the source of this image as a bitmap, and we read it from the resources from here. You see, this is why we put all of our icons here in the resources folder, and we chose the build action by right clicking it from properties as resource. Now when we use it like this, our application will go find that in the resources folder and use it. And the height and width of the icon is set here. I used 50, but you can also, for example, if you want to make something with multiple resolutions, you can give it a ratio of the Treeview. For example, you can write TV stock vehicles dot actual width divided by 10. This way, when your Treeview gets stretched, or if it's displayed in a bigger screen, the icon sizes will change as well. But for the sake of this lesson, I just write it 50. So label is the text next to the icon. It's the same as creating an application in standard XAML in your main page, just like writing it. Think of it as writing it in XAML. So if I just add a button here, but you're doing it from code, and instead of doing it in the window, you're creating objects and putting them inside the box of the header. So the Treeview header is the type of object. You can put anything in it if you want. You can put a stack panel in it. You can put a canvas and make drawing on it. You can put a view box and display something on it. You can play a video. This is the powerful points of WPF. So because it's an object, you can use any type you want. So in the main header, I prefer stack panel. And inside the stack panel, I will put one image and one label for my icon and my text. And then after I create my label, the content will be the brand name with one space and the model name. This information is derived from the car class, information class. So as you see here, this is the car brand name and this is the model. So this is two different data combined. And then I add it inside the stack panel. After I add it in the stack panel, I just declare my Treeviews header and I say it's equal to this stack panel. So what I do is I create one stack panel and I use the stack panel. I just inject it inside the Treeview item. And then I add this into the Treeview. So let's see so far what's happened when I debug my test project. Okay, you see, I have one main header because we didn't declare any items under it. We just have the main one. So far so good. So this is our main header, and for the motorcycle we will do the same. For the bicycle we will do the same. But I think it will take a lot of time if I do this for each of the Treeview items, because I will have to copy and paste the same code and change so much stuff. The things that I really need to change here are the icon for a photo. The image of the icon must change, and the tag. These two things have to change. The other thing is already parametric. We will just use the brand name of the object and the model name of the object. So in order to shorten up the code writing process, I just created one method that's named create basic root tree item. Instead of writing this code, which we saw, I just write one line and it just creates me one root Treeview item. So also I did the same for child nodes, because for each child node I have to write the same block again. So it's not necessary. So I just created a method to save me the time from writing all of this. So I will copy my methods and we will go over them. So I have three methods. One is for creating the main Treeview items, like this one, which shows if it's a car, motorcycle or bicycle. This is the root node, root Treeview item. Under this there's the subcategories. For this I used another one because it's possible that when I create a root Treeview item, maybe I want the icon to be bigger, or I want the format to be different, or the background color, maybe I want to set a different background. So I created separate methods for the root nodes and the child nodes. And finally, as you see, the lowest level node, the data input node, is totally different. It's basically two text boxes, and one of them is able to write and read the data. So I have three different methods. One is the root node, one is the child node, and finally the data node with the text box. So the first one is the root node. As you see, it's basically the same method with the same code. Only difference is there's the icon name here passed inside the method, and there's the tree view to add, because maybe I will use this method. If my app has two different tree views, I can use one method with many different tree views. And header string, this is basically where it wrote Toyota Corolla. It's the string of where the header is. And we have the tag. As I said before, I also declare the tag. In the future we will use the tag. So it's the same block. The only thing is the variables are passed inside a method. So I don't need this anymore. What I will do is I will just copy this simple one-line method, and it's done. Yes. So for each node we had one block. Now we just have one line. And now we have a root node, so we have to populate the children node. And for this, as I said, first I'm going to show you the main block, and then we will use the method to shorten it up. So after this root node, I will add a child node. So I need to know the index of which root node I'm at, because I created this node and I need to catch it. So I just create an integer. Okay, so the child node is asking me which root node should I be added under. So after I add the root node, I just get the index of the root node by selecting the final tree view item, and which is -1 from the count. Index of parent tree item. And each child node's tag will be the index of the root node. This way, when I click on it in the future, or when I select it, and I can just read the tag of the click tree node, and I will know which vehicle I'm talking about, because inside this vehicles in stock list, the objects are located, and if I want to change any data, I need to know which object I'm changing. I need to know the index, so I will find it in the list and change the property value. So I use the tag to pass down the information to the children. Each child tree view item tag will be the index number of the highest parent. So when I click on electronic, I will know that electronic is the first one. The 0th index in the tree view is this one, the Toyota Corolla. When I click on electronic, and when I go under electronic and change like this one property like this, I will know that I am changing the information of the 0th index object inside the tree view. In order to know the index number, I just pass it down with the tag. There's another way to do it. You can like use the parent of click node, but as you know, we have a nested tree view. There may be like, maybe if I'm inside the mechanic category, the engine has two parents. First parent is mechanic, second parent is the root node. But if I click on info, it only has one parent. So in order to not deal with any of this different category parent counts and problems like this, I just write the index number of the object in the tag and use it. And the story is same. We just create one stack panel again, one image, one label, add them in the as children inside the stack panel, and then I declare the header, and at the end I add this. You see index of parent tree item. I select the root tree view item, which holds the index of the parent, and under this tree item I add another tree item. So in the tree view there's unlimited levels. So a tree view item is like you create one tree view item and you add another one under it, and the one under it is also a tree view item, so you can add another one under it, so it can go infinitely like this. So the first tree view was added into the tree view. It was added into this UI element, the main control. We said tree view items add tree view item. So we added this tree view item inside the main tree view, but the second children tree view items will be added inside another tree view item. So this is different. Before it was called nodes in Windows Forms, so there was like parent node and children nodes. In this one it's called tree view item, so it may be a little bit confusing. So as I said, for each child tree view item, writing a block like this is unnecessary. So we have a method for that. Create basic child tree item. And in the root tree item, you see we have a property named treeview because we add the roots to the treeview directly. But the child tree views, we add them inside another tree view item. So the first property is which tree view item will this be added to. The second is the icon PNG name, and the other is the header string, and the other is the tag. So basically it's the same code block, only difference is the name of the PNG is different. The size of the icons are smaller because they're children, and the tag is read from here. And then finally we have this. Also, this error will be solved later. For each level of treeview item, we can assign different events. For example, when I right click on the main treeview item, I want one event to be triggered, and this will be declared here. You see, I just write preview right mouse button up event is this, and when I create the child treeview, I use this. And when I trigger this event, when this event is fired, okay, I need to know which treeview item I clicked. So inside this event I will make something with that treeview. So I need a buffer variable. So I will just make a buffer variable. I will show you what I mean in a second. So I will create a treeview item. as a global object. I can reach everywhere. I will write it in the main code area. So you see, right click Treeview item. When I go in this event, I will also copy this event from my main code. Okay, so now I have this event. When right mouse button is up, it will go to this event, and this event is here. It declares the right click Treeview item, that's here, our buffer Treeview item, the global one. I say sender as Treeview item. So when I right click on it, I catch the right click Treeview item, and then whatever I want to do something with it, I know which Treeview I'm working with now. And then I open a context menu, and of course when I want the context menu to be visible where my mouse click was made, so I set my parameters here, and inside this context menu there's a delete button, and the header of it is delete. And when I click on this delete button, it will remove the chosen object from the list of data, and also it will remove the object from the Treeview. So I need to remove it both from the Treeview and the source of Treeview. As you know, we made custom templates. We don't have a data binding. So when you delete it from the Treeview, it doesn't mean that the object is deleted from the data list. So I need to follow both sides together. As you know, when I right clicked on it, I got the right click Treeview item in the buffer. So now when I click on the button of the context menu, I will just use the index of the right click Treeview item. I will find the index of it in the Treeview with using TV stock vehicles items index of right click Treeview. I know it's the index number, and the same index number is also inside vehicles in stock. So if I delete both indexes from the Treeview and vehicles in stock, my object will be deleted. And this is the right click event of the root Treeviews. But if I want my Treeview, if my Treeview item is a child, when I right click on it, I don't want to see the delete option. I want to have something else. So the event of that one is, it opens a context menu again, but this time it says paint red. And when I click on this, the button paint red, what it does is it triggers paint red preview mouse down. So it just paints the background of the Treeview item to red. This is just sample events. In your application you can modify this whatever way you want. So let's see how far it's going. But first let's add the children. Okay, so now we are starting with second levels. So we have our root Treeview here, and we have the index number of our root Treeview, by using this index number, we are adding child nodes under it, and you see we are using our root parent tree view item index to catch the tree view, and then we are declaring the name of the PNG. You can see the information here, icon PNG name, it's info. It means there's a PNG named info here, right here. It's using this PNG inside resources and creating a child tree view. And this one is the header text, the header string. And finally, the tree item tag is the parent's index number. And then what I'm doing is, if I want to use this child tree view item in the future, I'm using it again. So as you see, I didn't use this because info doesn't have a subcategory. I don't need to add anything under it in the future, but just in case I need it, I saved it as a tree view item. What I did is I got the parent item, and under the parent item's children, I got the final child, which is count -1 index, and then I declared it as a tree view item. So now if I want to add a child node under the info section, I can just click tvi info1 dot add dot items dot add whatever. And then I don't need I'll just keep this comment. We have the second category, mechanic, and it's the same. The PNG name is mechanic, the header string is mechanic, and the tag is parent tree item index, and I added the second level. And under mechanic, there's the subcategories of mechanic, which are engine, transmission, and chassis. TVI mechanic 1 is the tree view item that I added before. So the subcategories of TVI mechanic 1 will be written like this, because the subcategories go under mechanic section. And electronic interior body is also another main section. So basically, this group, this is one subcategory, info, this is the second one, mechanic, and under it, it has mechanic subcategories, and the remaining three is electronic interior and body. As you see here, info, mechanic, electronic interior, body, and under mechanic there's three more. So this line is where we add engine, transmission, and chassis. This three, engine, transmission, chassis. It's basically the same method, you just change the variables and populate them. And finally, let's check our test project, how it's going. What's wrong? Yes, we have something missing. Okay, we're not here yet, so I'll just comment this out for the moment, because we don't need that at the moment. Okay, so we have our main root tree view item, we have subcategories, and we have three other categories inside our mechanic category. The only thing remaining is the data input levels. So now we will do that. Okay. So we have the main levels, the root level, and finally the lowest levels. So this is the final level of info. So we have a method named create data child tree item. We have the parent where this tree item will be added. We have the caption, the description of the parameter. We have the name of the text box, which is where we will write the value. And we have the tag again. So when we change a text box, we will know which object this parameter belongs to. And finally, we have the brand name. So when we create this text box, we will write the value that's read from the database. So I want to explain this to you more, because this level is different. Before we use the stack panel as our tree view header. You see this is our stack panel. Because our structure was one icon and an explanation, but now the situation is different because we want to make something where we can write information. So we need two text boxes next to each other, or it can be one label and one text box, not important. I just prefer using a text box in making the is read only property to true, so it's not clickable. Because the size of the labels, the border sizes are not the same, so I prefer using a text box. So it's up to you. You can do anything you want. In here, you see we declare the Treeview item, and here I gave a margin to the Treeview item. The reason why I gave a margin to the Treeview item is, let's see how it looks without a margin. And also I will show you how it looks without the width property. So you see it looks like shit because the size is depending on the input, depending on the whatever is inside, so it doesn't look nice. So what we will do is, first, because we want the two text boxes to be equal in size, we need to use a grid. Because the stack panel is something that you put everything next to each other, and the width is not something that can be automatically calculated. But if I use a grid, I can change the width of it, I can stretch it, I can do whatever I want, and it will keep the ratio. And also, one more thing, as you know, in the tree view, by default, when I click on one node, the other node has an indent inside. It's a little more on the right. So when I click on this, you see it's on the right. But when I have three levels, like in mechanic, you see it goes all the way inside, and I have to make my tree view much more bigger in order to see the data. So I don't want to make it bigger. I just want to move the final level more left, because I already reached the final and it's obvious that I'm at the final, so I don't need this useless empty space on the left. So what I do is I just set a margin, and as you know, margin is set programmatically like this. It's the same thing by setting a margin from XAML, but in the program you have to do it like this. And I set the margin by giving a ratio from the actual width of the tree view, because if I write a fixed value here like 50 or 70, when the form is stretched, or if the resolution of the screen is different, it will look bad because it will be 50 pixels, and 50 pixel is bigger in a lower resolution screen. So what I do is I just give it a ratio with the actual width of the tree view, and I do the same thing with the grid as well. So I want my grid to be a little more smaller than the total width of the tree view, so it doesn't exit outside of the right. So basically what we do is we create a 2-column grid programmatically. It's easy in XAML, but in code you have to do it like this. It's the same thing. You create one grid, you can define the width, and then you have to add a column definition under the column definitions. Actually, we're doing this. We're creating a grid and we're adding column definitions under it, but we're doing it from C#. And also the width will be like this, 1 star. As you know, here we have stars, which give us the advantage of equalizing all of the columns. In here it's the same thing. This is the way of writing the stars. So if I put 2 here, it will be 2 stars. So I want them to equally be wide, so I gave them both 1 star. And the text box caption will be the caption passed inside the method. And you can change anything, customize everything at this point. The back color, the fonts, font sizes, everything. And I put the tag here. And finally, I add the 2 text boxes inside the grid. And different than the stack panel, when you add something to the grid, by default it will be row 0, column 0. So I have to set the column and row number. Because our grid doesn't have any rows, it's a single row, I just need to set the column. So what I do is column of header text will be 0 and column of the data will be 1. And finally I set my header as the grid and add it to the tree view. And then when I change the data inside from here, for example, if I change something here, also I want my data to be updated. When I press the enter key or change something and go focus out, so I need to connect this to my source. To do this, I just create events. Do not use text changed event, because text change event is very messed up. It causes chain reactions and it turns everything into shit. I especially avoid using text change events, because you know what happens when the form opens up. Okay, when you load all of the data, first you create it, and then after you created it, when the text is set, it causes one, like when the UI element is being created, when you read the data from the database, you have to change the text, and when the text is changed from the database, it triggers the event again, and then the text is changed again and again. So you need to go inside text change event, and you need to write like if the previous value is not same with the next one and stuff like that. So the easiest way is just don't use it, because whenever you have a problem that's caused that you don't understand what happened, 99% it's because of the text changed event. It causes loops and crazy stuff like that. So what I did is I just changed the preview key up event and lost focus event. This will be enough, and these events are inside our previous project. So both of these events just save the data in the text box into the object, the source object. And how it does that, it just triggers a method named save text box data, and you pass in the text box, and let's see what's inside save text box data. Okay, so if our object, edited object, is, as you know, when we created these text boxes, this is also very important. When you create the text boxes, the name of the text box, okay, the name of the text box, which is set here, the property name is brand. Okay, so car.info.brand, car info brand name. Okay, car.info.brand name. What I do is, when I create the text box for brand, there's a mistake here, by the way. Okay, so this is car.info.brand name. The name of the text box is TB brand name, same name of the property. This way, when there's a change in the text box, I can simply know which property I should modify. It's a simple trick I always use, and it's like extremely helpful. It saves you from a lot of trouble. It's basically a simple binding method. I bind this text box into this parameter in my own way. So what I do is, if edited object is, as you know, the tag of our root Treeview item was the index number. So what I did is, when I clicked the text box, I got the tag of the text box, and it showed me the index number of the object. So I simply just got the 0th index inside vehicles in stock, which is the car. And then I got the property name from the name of the text box. I just jumped the TB part. As you know, the name is TB brand name, TB gear count. There's a TB at the beginning. I skipped the TB part, and I read it as the property name. So now I know what type of object my property is, and I know the property name. So if the edited object is car, I just cast it as a car, and then I simply write if my edited property is a brand name, car.info.brandname is my text box. I just make a connection between each parameter and each text box like this. This way, whatever text box you change, it will directly modify the list of objects that's inside your database. And then you can do whatever you want with it. And if it's a motorcycle, as you know, the parameters change depending on the category. So for each category of objects, I just make a simple method like this. And this is the way to change the data by two ways. And finally, the same thing happens in motorcycle and bicycle. The only difference is they have a few less categories, but I'll just copy them as well. Also, I see that before I used v.getType equals type of bicycle. You can also write it like this, it's the same. Or you can write a shorter method is if v is car or if v is bicycle. It's the same thing. So as a summary, what we did is we created sample vehicles, which each of them are classes: car, motorcycle, bicycle. These classes must have the same hierarchical level. The hierarchy must be same as the tree view. As you see, under the car class there's info, and then there's directly the parameters. Under mechanic there's 3 more subclasses, and under these subclasses there's the parameters, and the remaining classes also don't have any subclasses. This is the same situation here. As you see, we have main class, 5 subclasses, and under info we directly have parameters. Under mechanic we have 3 more subparameters, and our classes must be designed the same way. After we design our classes must have initializers here. So creating the class is not enough. This is only showing that there's an object type like this, but the object still doesn't exist. So we need to create one, enable to access and set the parameters inside it. We have a list of objects. This is the list that we will populate from our database. We will read our database, convert it into cars, bicycles, or motorcycles, and fill them up in vehicles in stock. And then in the window loaded event, this is important. In WPF, after the window is rendered, the actual width and actual height can be used. So you need to use window loaded if you want to make calculations depending on the visual width and height. It's easier to do it after window is loaded, because the actual width is then visible. So what we did is, after the window is loaded, we started creating the tree view items depending on our database. So we separated, if the object is a car, we created a special designed hierarchy specific tree view item with sub tree view items under it, and we created 5 sub items. Under them, only the mechanic sub tree view item had 3 more sub tree items like this. And then finally, under each one of the subtree items, we have the data input Treeview items. And these are basically two text boxes inside a grid with two columns. Left side is the description, right side is the parameter. And we have the node that it will be added under. We have the caption, we have the text box name. The text box name is the same with the parameter name. It has TB in front of it. Later we will just remove the TB and understand which parameter to edit from the name of the text box. And also, as the tag, we pass down the index of parent tree item. So when we change a text box, we can read the tag of it and know which object it belongs to. We will use that index inside vehicles in stock to find the index of the item. After that, we assigned events, and our save event is here. So this is a save text box data event. As I said, you can use text change, but it will cause you problems in some cases. So we used preview key up and lost focus. Actually, preview key up, it's better if we use only the enter key. If e.key is, if e.key equals key enter, only if we press enter key it will save it. This is better. And lost focus. And this is our save block. If we understand that the object, the number of the object, the index of the object from the tag, and we understand the name of property from the text box name, then we know the object, so we can check if the object is a car, a motorcycle, or bicycle. And finally, we set the data depending on the text box name. So if it's brand name, we'll change the brand name. So the sample is in the GitHub link under the YouTube video. I'm sorry, maybe my speech is a little slow or something. I'm not a native English speaker. I hope I'm able to help you in your journey of software developing. In the future, we will have some videos about C# and also some automation, because as you know, I'm a software developer for machine industry, and it's a very interesting industry. I want to share my enthusiasm and passion with you. So at the moment my videos are mostly based on C# tutorials, but we will also have videos about machine automation. It will be interesting. It's difficult to run a full-time job and make videos for this channel, so I'm waiting for your support. I hope you can subscribe and support me in my journey. I just want to share my enthusiasm with you, so please subscribe and like my videos for support. Have a nice day, you guys, and keep on working. Don't lose your passion, because this is a hard job, and sometimes you can get, it can have some challenges psychologically, because we are always using our brains at maximum potential. It's sometimes fun, but sometimes it's very exhausting. So take care, everyone. Have a nice day.